Welcome to AP Calculus AB, section 3.5, page 2. And we are going to be doing some examples of the derivatives of the trig functions today. We're going to start right here with this one. F of x is 4 sine x. Find f prime. All right, when we see a constant multiple here, so a constant being multiplied by something, then that constant multiple just comes down. And we have 4 times the derivative of sine is cosine. So f prime is 4 cosine x, and done. If we look at this one over here, g prime, again we have a constant multiple, so that constant multiple just follows down. The derivative of sine is cosine. Now this second piece, that becomes an issue. This x right here is not a constant multiple. This is a variable being multiplied by another variable piece. So we have a product rule going on here. Then we need to do that product rule. So first times derivative of the second, which is negative sine x, plus the second cosine x times the derivative of the first, which is 1. Simplifying and distributing that negative sign through, we have 3 cosine x plus x sine x minus cosine x, which will leave us with 2 cosine x plus x sine x. And done. That's our answer. There's your derivative. When we look at this one, we have a huge quotient rule to do here to find this derivative. So here we go. Bottom cosine x plus 1 times the derivative of the top. The derivative of sine is cosine, and the derivative of that minus 1 is 0. Bottom derivative of the top minus top times the derivative of the bottom, which is negative sine x, all over the bottom squared. Simplifying, we'll distribute this cosine through, and we have cosine squared x plus cosine x. All right, be careful over here, because we have that minus sign to distribute. I'm going to take that minus sign to that negative sine x, and then all I'm doing is really just distributing a sine x through. So we'll have plus sine squared x minus a sine x all over cosine x plus 1 quantity squared. We have some like terms. Well, they're not like terms, but we can combine some stuff here. We have this cosine squared plus sine squared, which is 1. So we have 1 plus cosine x minus sine x. That is all over cosine x plus 1 quantity squared. Nothing else simplifies. That's the derivative right there. For this one, we'll have to find f prime of x first. We'll do a derivative here, and then after we have that derivative, then we'll evaluate at pi over 3. So let's find f prime of x first. Again, a quotient rule. Bottom x times the derivative of the top, secant squared, minus the top, tangent, times the derivative of the bottom, which is 1, all over the bottom squared. And we'll just clean this up a bit. We have x secant squared x minus tangent x all over x squared. That's f prime. But we want f prime at pi over 3. So we're going to plug that pi over 3 in for x here. That'll give us pi over 3 times the secant squared of pi over 3 minus tangent pi over 3 all over pi over 3 squared. Oh my. All right, pi over 3 times. Now, we need secant of pi over 3 and then square it. So we have to remember back to pre-calc. Pi over 3 is up here with coordinates 1/2 square root 3 over 2. Cosine here is the x coordinate, it's 1/2. So secant there is 2 squared minus tangent of pi over 3. All right, tangent is sine over cosine, so square root 3 over 2 over 1/2. That's just square root 3. This is all over that denominator squared. Pi squared over 9. All right, still cleaning this up. Oh, and this looks like 4 pi over 3 minus square root 3 over pi squared over 9. All right, now, complex fractions. We don't want to leave complex fractions. So one of the things that you can do to clear the complex fractions is to multiply the numerator and denominator by the common denominator of all the denominators. And the common denominator of all the denominators is 9. So let's multiply by 9 over 9. When we do that, this 9 times 4 pi over 3, the 3 and the 9 cancel as a 3, so that's 12 pi minus 9 square root 3 all over, and then 9 times pi squared over 9, that's just pi squared. There's f prime at pi over 3. Final answer there. Take a look at this last one on this page. F of x is 4 secant x minus 5 cosecant x. We want to find f prime at pi over 4. All right, let's find that derivative. F prime, constant multiple, just comes down, so 4. The derivative of secant is secant x tangent x minus, this 5 is a constant multiple, so that comes down, times, and then the derivative of cosecant is negative cosecant x, cotangent x. And cleaning this up a bit, we'll just make this minus 5 times that negative, a positive 5 cosecant x, cotangent x. And now we're going to evaluate it at pi over 4. It is worth your time to write this out where you physically see that you've put in the pi over 4. Okay, cotangent and pi over 4. Pi over 4, smack dab in the middle of the first quadrant. Ordered pairs here, square root 2 over 2, square root 2 over 2. I need the secant of pi over 4. All right. Cosine is square root 2 over 2. So I want the reciprocal of square root 2 over 2, which is 2 over square root 2. Let's rationalize. We get 2 square root 2 over 2, which is square root 2. That's the secant of pi over 4. It is worth your time to memorize that. The secant of pi over 4 is just square root 2, so that it comes faster. I mean, it doesn't take too long, but it just comes faster if you know that. Secant of pi over 4, so that's square root 2. Tangent of pi over 4, sine over cosine, that's 1, plus 5 cosecant of pi over 4. Well, that's the reciprocal of square root 2 over 2. Same thing. Square root 2. And the cotangent of pi over 4 is 1. So we have 4 square root 2 plus 5 square root 2, or 9 square root 2. There is f prime at the house over 4. Thank you very much. Please join me on page 3.